Wow, this is fantastic. We are going to have some Wi-Fi issues. We're seeing it. If you're not seeing it, yeah, all right, good. Hey, hey, so welcome to the Using Istio workshop. I wonder if I'll learn something today. It's possible. Service meshes do a lot. Anybody want to call out something they think a service mesh does? A reason why someone might use a service mesh? It's on the tip of so many of your tongues. Very good. Security. Very good. Visibility. Circuit breaking. Very good. All of the above, depending upon your service mesh, which in and of itself is maybe a bit of a, like any new tech term, probably needs a bit of a definition, a bit of a clarification about what is a service mesh, what qualifies as one. I think I can't blame any of the projects or of the vendors for wanting to take that super buzzy word and maybe just sort of rub it up against their project and things, and who am I to suggest otherwise? The specific service mesh that we're going to talk about today is Istio. Istio is large. It attempts to address, or does address, a fair number of concerns. As such, it's probably an interesting place for vendors to extend or for integrations to be incorporated. Also makes it very powerful. It also makes workshops like these very interesting because there's lots to talk about. As a matter of fact, we've given this workshop a number of times over now. We will not make it through all the material today. I was anticipating this was more of a 3 to 4 hour session, and guess what? It's going to be a super jam-packed 90 minutes. It's going to be exciting. Some of you I'm seeing have already gotten a jump on the gun, and you've headed out to, you've probably seen a tweet from me that said, hey, go to this URL. I'm not going to distract you now with what that is, but I'll say that you may have seen some other tweets from me, maybe, at the last time, what was it? Well, it was DockerCon EU, but Velocity London, and I couldn't help but just notice randomly the consistent wearing of Argyle socks. That, for those of you who are looking for some tidbits about my particular fashion sense, apparently it's Argyle socks. That's all I ever seem to pack. There's a reason I brought that up today. I wanted to talk about another piece of fashion, and it may come to me. I'm blank. With that, though, to hurry up and get into some of the material, to hurry up and hopefully warm up our fingers, these are some things about me. I wear a few different hats. I'm involved in a few different ecosystems. If you were unaverse to dad jokes and corny, dry humor, there's more of that there. Really, the reason to show this slide is really much more about the notion that not only this talk, all of its resources, and a number of other talks are at the calcotestudios.com/talks URL. So if you're feeling anxiety about the fact that we may not make it through all of the talks, all of the labs today, which we won't, and or some of the material gets glossed over quickly, point of reference. I'm joined today by Girish Ranganathan. Girish is at full-time focus at SolarWinds. Folks familiar with SolarWinds? Curious. It's interesting to take a survey at the epicenter of cloud native. Now I remember why it is that I brought up fashion. And that's because I left my belt at home today. And so I did bring my Argyle socks, but if you see me doing this, it's because I'm beltless today. So another fashion tip for me, those are free. Some other things I want to talk about are microservices. We don't have to talk about microservices, or rather service mesh in context of microservices, but the value that service meshes provide is probably most prominently seen in these types of environments. This is where you're going to come to understand that there are many, this isn't the microservices talk, but you're going to come to understand that there are benefits to doing things in this architectural style. Here's a couple of top benefits. There's also maybe a couple of top detractors. Some of those detractors are maybe squarely addressed by a service mesh. So one of those is that as you get a lot of services, and oftentimes put inside of containers and maybe on a container orchestrator and rescheduled, moved around, that you may find yourself running a bit blind, trying to understand where the heck these things are and how they've moved around and what node they're on and who's talking to who. And Service Mesh provides for an understanding here, for observability. It does so in a uniform way. So kind of to the second point, that if you're doing microservices today, if you're trying to overcome, I think someone said, or instrument or implement circuit breakers or do retries, someone had called that out. These are things that you can do with client-side libraries, GoKit, Hystrix, .NET libraries, your language of choice. So while there's freedom to choose your particular language or the best instrument for a given service, as you go to address some of those distributed systems concerns about what happens when one service can't talk to another, or what happens when one user is being abusive of my API, how do I rate limit them, how do I tell them to back off, how do I do canaries in a controlled way? Service Mesh's attempt to address these. So some of the monitoring or some of the tooling that you use today may be a bit outmoded. Vendors have been working hard in the space, and projects have been working hard to overcome some of their former architectural choices. When infrastructure used to be a lot more static, things are a bit more ephemeral now. So why use a service mesh? Well, it's to overcome some of the challenges we just talked about. It's to maybe avoid building in infrastructure concerns directly into your code. Maybe it's to hand that off to a different layer, a different independent layer, the service mesh layer. Let it deal with some of these concerns, the rate limiting of calls, the retrying, I don't know, maybe injecting some chaos, introducing some latency and some jitter. Having fine-grained granular control over the traffic within your cluster, having it be more secure. These are some reasons why you're going to want to use a service mesh. Turns out getting some of those distributed systems concerns correct, how often to circuit break, how long to back off, how frequently to retry, when to quit, hard things to get right, done differently using different libraries in different languages that become coupled to your application code. And if we're here to really focus on the application and we're running the infrastructure and are concerned with infrastructure and running it well for purposes of the application, then to the extent that we can separate these two concerns, all the better. We can do application releases independent of maybe how we're configuring some layer of our infrastructure. We're certainly seeing that today with container orchestrators, being able to address those as an independent capability, irrespective of the application. Service meshes are going to provide, not always, but most common, often deployed. Well, you got to watch some of what I'm saying here. It's true. It often deployed on top of a container orchestrator. Don't have to be. Again, I think that the more services you have, the more prevalent some of these challenges are going to be, the more benefit you're going to find from a service mesh. So I mentioned the container orchestrator. Some of you are maybe asking this question. Hey, I thought that's why I had a container orchestrator, and it was going to deal with keeping track of rescheduling things and figuring out and tracking where they're going and service discovery, and hey, my container orchestrator does some amount of application health checking and some of these things you're talking about. So what's the deal? I'd gone around talking about container orchestrators for a long time, and had postulated that if a container orchestrator, if a project, if it didn't have cluster management and scheduling, the two things in yellow, you couldn't call it a container orchestrator. A couple of years ago, we were trying to figure out whether or not to call it container orchestrators or something else, and which one's qualified. And in a lot of respects, that's been kind of my definition. Container orchestrators have had their focus on infrastructure concerns, necessarily so. We've got to start there and deal with distributed system concerns at those lower layers. You're going to hear me bastardize the OSI model a little bit today, but I think it's well intended, and maybe it will be helpful. But if, in my mind, container orchestrators are most prominently focused on layer 4 on down, doesn't mean that they don't do layer 7 things, or it doesn't mean that many of them over time aren't providing for application level concerns, the code that's, the workloads that are running inside your containers. But they certainly don't address all of what your application needs. Another common question, another piece of infrastructure that you're probably, or you might be running, is an API gateway. Common question to say, hey, of the things that the API gateway is providing, rate limiting, for example, I hear service mesh is providing that as well. So does this mean I need to get rid of my API gateway? Are these complementary? Should I use both? Well, the beautiful answer there is, no, it depends. Let me characterize the API gateway as being probably primarily concerned with north-south traffic, whereas the service mesh is a bit more centered around east-west traffic, so cluster traffic. Certainly, the service mesh ingresses and egresses traffic out of the cluster as well, but you'll often find a deployment model where you've got an API gateway out in front of your cluster, that coming through ingress into something like Kubernetes, and then into the service mesh itself. We're going to get some illustrations going on here in a minute and hopefully make this a bit more real. Okay, so if we continue to need a container orchestrator, continue to probably need API gateways, we continue to need actually a litany of other things within our cloud-native environments, our cloud-native deployments. What are some of the things that we're missing? Hopefully you've begun to hear me say a few of these. One of these things that I maybe haven't said is, observability. There's a lot of traffic, network requests that flow through your microservices. The importance of the network couldn't be more prominent, maybe outside of a distributed system. Super critical to how it is that your services are responding, and getting insight, just sort of immediate insight without changing code into logs and metrics from those network requests. Also, facilitating distributed tracing for those requests. We're generally talking a lot of HTTP here, or H2, and some other protocols are making their way into service meshes. Clearly, what you need is a service mesh. Briefly, because I want to get into the labs, I think we've got, by the way, 10 labs. We make it through 4 labs, that'd be awesome. I don't want to jinx it, but if we make it through the first one based on conference Wi-Fi, that would also be fantastic. Fortunately, I didn't drive my car here. You cannot go out and key it. Moreover, it is not my fault, the Wi-Fi, so just, this definition, makes things, very obvious what the heck a service mesh is. It's one of those more formal definitions that probably doesn't really communicate to you meaningfully what they are. Some people have described them as a microservices platform, partially, maybe. Others, including myself, would articulate it as probably a services-first network. Services meaning your microservices, your applications, being concerned with them and their needs of the network. I'm going to go through some more specific examples. We've called out a few. Point being is orchestrators perhaps don't get you all of what you need. Neither do service meshes. It's not a utopia. They're also missing some things in the space. There's potentially some need for additional tools around distributed debugging. In terms of how you run your distributed, your microservices, distributed debugging, better visibility. We're going to see a little bit of visibility, but there's emerging projects that are providing, and some vendors that are providing much better visual representation, visual topology of what's going on. All things maybe should shift left. Like, is that bad if they do? The service mesh in general, if I can say the service mesh and sort of refer to them all. My hope is that some of them are going to shift left a little bit. Maybe integrating into the CI systems. Maybe, to the extent that they facilitate canaries and fine-grained traffic control, maybe we could control that a bit earlier in the pipeline. Someone go start that up and then come back and I'll take a stake. Lastly, here, and I think we get into labs after this. Another OSI model, tongue-in-cheek. Service meshes land at layer 5 for me. Layer 5 is the session layer, to take you all back. I think the concept there is service mesh is sort of the next, in my mind. Not everyone follows the same cloud native trail, if you will, or this path, but a lot of times things start with containers. Move over, you get enough of them, you go into container orchestration, you get enough services running in there. Turns out you need another layer of tooling, service mesh. This layer, I think, helps decouple ops and dev a little bit. Not that we don't want these two groups working super close together in the same team. It decouples to the extent that today, I guess let me ask you this. Here's hopefully a thought-provoking question. In your environments, who's responsible for defining and enforcing a rate limit? Or implementing a circuit breaker? Who determines when that should go off and how? How often you should retry? I keep using a lot of the same examples. Service meshes do a lot more than what I'm referring to. Sometimes, certain environments, that's the developer. Maybe in certain environments, that's the operator. Today, more often than not, we probably find that people are addressing these concerns in their application code, which probably, going back, as a reminder, again, means that you'd have to do a release of your application code, roll out a new version if you wanted to change any of those, the way in which that traffic flows. And if you're using multiple languages, you probably aren't necessarily getting uniform observability out of them. The telemetry that's coming out may not be the same. The way in which those libraries behave and the capabilities of those libraries to control the traffic and to provide various things, it probably isn't the same. So a service mesh provides uniformity here. It also, and to the point of helping dev and ops iterate a little bit more quickly, and maybe diffusing some responsibility. Actually, if any of you, when I ask those questions of, hey, whose responsibility is it to, define the retry count? If any of you were like, well, I'm not, I think, half the time it's, I'm not sure, that responsibility maybe is diffused, or rather, sorry, confused, and maybe bringing in an additional layer helps diffuse the responsibility. Helps say, actually, here's a separately addressable tool to control these things, to provide the observability, the encryption, the traffic control. And you can do it declaratively in YAML, and that can be versioned, and maybe doesn't take another release of your application, and so hence can iterate a bit independently, and teams can address it. So. Okay, with that, maybe literally warm up your fingers, get the Wi-Fi revving. Let's jump into the labs. Not only was the other URL that I mentioned an excellent resource, and we'll point to here, but much of today's labs will be on layer5.io. You'll find the site itself is a bit of a community-curated set of information about service meshes. You'll find some other resources you may or may not find interesting. But maybe as a first step, both to facilitate some in-class questions in and amongst each other. Maybe some of you are able to address questions from one another. Go ahead and join the Slack. We'll be joined here. The Slack is a persistent account, a persistent channel from many of the conferences that we've given talks at. So you will find others who are virtual former classmates of yours, folks who've already moved the tassel over, who probably have some questions. So maybe a good place to engage and interact. With that, we've sort of preemptively said, hey, maybe to avoid some of the Wi-Fi issues we have, it never hurts to maybe use an external DNS in this environment. You can go ahead and switch if you want to, or we can just proceed at any point, just a good troubleshooting step. If you're having trouble, maybe give an external DNS a shot. Okay, first lab. So we're here at KubeCon. Hopefully, many of you are sort of along your way in the journey where it's, you're familiar with Docker. Hopefully, many of you actually have maybe Docker for desktop installed. To the extent that we have Wi-Fi issues, we're going to resort back to probably that tool. We shall see. First lab, if you go to layer5.io, you'll find a link to the GitHub that lays out all of the labs. These are all the labs. The first one is to go ahead and set up a quick Kubernetes cluster. Today, hopefully the only thing you need is your browser. And you can, if you're familiar with Play with Docker, there's also a Play with Kubernetes. Thanks to our friend Marcos Nils, a co-Docker captain of mine, and to some work that Girish has done. what you'll do is bring up a couple of screens, of pages. So in one, bring up the workshop itself and the overview. First one, setting up Kubernetes. Second thing you're going to want to do is go out and go to PWK, playwithkubernetes.layer5.io. You will hopefully get a session established on your own PWK, your own Play with Kubernetes environment. In there, we're going to go ahead and create a 3-node Kubernetes cluster. Hopefully do this relatively quickly. The second lab, we're going to go ahead and deploy Istio. Third lab, we're going to deploy the canonical sample, a little bit of the modified canonical sample application, book info. And we'll see if we can get into the fourth lab. So you have PWK up. Okay. Maybe a quick survey. I did see a few folks as I was walking around that already had Play with Kubernetes up. What's the best way to ask this question? How many are able to bring up the pwk.layer5.io? How many have a session there?
Right. So the username and password is actually on the data page, but essentially it's the username is student and password is Istio 2018, all lowercase. One thing to note is that, this is like a shared environment. We have some pre-deployed set of nodes. So as soon as you're prompted for a username and password, try to enter the credentials as quickly as possible, because without which, your session will get killed. Unfortunately, that's a cleanup process I have to do. Otherwise, sessions are getting wasted. So, try your best.
Yeah. So good. Let's repeat. Yeah, so if you go to layer5.io, you'll find the links to each of those things, both to GitHub. In GitHub, you'll find the password for the site. So username is student, password Istio 2018. All right, understanding that we had a significant number of hands raised, but not all, I think the fallback plan here is, and please don't go download it now if you don't have it, but is Docker for desktop. Super convenient way of getting up a Kubernetes cluster, a single node Kubernetes cluster. The lab will work on a single node or on 3 nodes. We're going to hopefully walk through 3 nodes up here, but single node will work as well. So again, if you don't get a session on pwk.layer5.io, pull up your Docker for desktop, go into your preferences, and maybe we should just show this real quick if I even.
So I'm sorry, I think he probably went past this a bit fast. So if you go to layer5.io and scroll down, you will actually find the current event, KubeCon 2018, or the KubeCon North America 2018, and there he's actually showing it on the screen now. So you have the labs, the links to the labs, are actually the GitHub material, and the lab resources is the PWK session and the slides and the Slack channel. So every resource is pretty much there. So you should be able to start from there. If not, you should pass on the keyboard, just go to PWK or layer5.io and probably try to invest in that session. So let's there. You can actually see from this machine that record moving flow. Not much of a sharp whiteboard.
Okay, so while that's coming up, the other resource that's been provided today for the labs is we're going to talk about Istio Mixer and some of Istio's points of extensibility. There's an adapter in there from SolarWinds. It integrates with Loggly, Papertrail, AppOptics. If you want to see logs or metrics coming out of your deployment, there's an optional lab that you can go through to do that. On layer5.io, there's a lab resources link. It brings up a Google spreadsheet. You could just grab we pre-provisioned about 100 accounts. You can just they're good for the day. You can go just put your name down next to one of them if you want to do that optional lab. Okay. So we're going to switch over to Docker for desktop. Okay, yeah, you want to switch over? Yeah, sure. You can just switch. All right, we're gonna do the switcheroo to Docker for desktop here. those that have got Play with Kubernetes up in your browser, the instructions on GitHub, we're gonna walk through this, but the instructions on GitHub are verbatim what you're gonna wanna do for the Play with Kubernetes environment. If you're running Docker for desktop instead, almost verbatim instructions, slight tweaks. We'll walk through it now, though. Okay, yeah, first lab.
So, if you go to the GitHub material, you can actually go to lab 1, and there we actually talk about getting a session on PWK or verified. That's the first part. Again, like I mentioned, credentials are there on the page, and I also mentioned about the 2 minutes window, within which you have to raise to get your session. If not, don't worry about it. So we have actually tested the material with. Whatever is happening here, once you're done with that, you can actually come back and then go to step 2 here, which is initialize the structure. As you're here, we'll presume that's the master. Now, again, if you're in this session, we are going to be talking about production grade, multi-master Kubernetes cluster. It's just going to be a single master Kubernetes cluster with total 3 nodes. So the same example is now, or the same is what is mentioned in the material here. So the first thing we're going to do is on this master, we'll be doing a 2 radius unit. Like a few moments, you can actually see that it actually does quite a bit of things, some installs and things. So I'll wait for this to come up. If you can read through the logs, you'll find a lot of interesting contents there. So you can actually see it does take a few moments. while it is pulling the container images and then like setting up a bunch of the things that are needed. Now, if you actually look at the screen, so here is the kubeadm join command that was part of the output. Now, this is very crucial. So every one of you is going to have your own join command, so you cannot like share between others, because every session is kind of like, you can say it's sandbox. So so whatever is in your sandbox, another person is not able to, will probably not be able to see it. So this kubeadm join is very important. So let's go back to the material and then follow, so you can actually see that I've also mentioned that if you're not using this PWK environment, if you're using your own kubeadm on a Linux machine, or if you're using, I don't know, a different play with Kubernetes environment, you probably don't need a Kubernetes version. You can just use the kubeadm init with a basic parameter. And yes, like I've mentioned, so here's an example of a kubeadm join command. So again, please don't use this. Use the one from your command output. Now, at this point in time, what we can probably do is that we can actually check the node status on this one. So right now we only have one node, and you can see that it says there's one node. The role of that node is a master, but it's not yet ready. The readiness here actually indicates that it's ready to start accepting requests for the loads or for deploying services, etc. We will be getting to it, or you will be seeing it becoming ready in the next few steps in this lab. Sounds good. Thank you. Cool. So the first node, the first command was actually the get nodes. So this actually gives the status of the nodes. Now, in a similar fashion, let's take a look at what pods were actually deployed as part of the first initialization on the master. And you can see it has actually deployed about 5 or 6 pods, and you can see pretty much some are running, some are still in the pending state, but that's normal. They'll become ready eventually. And I also have a sample output. Your output on your terminal doesn't have to exactly match the one here. What we have presented here is just a sample. And now, the next crucial thing is we have to actually deploy an overlay network. So for this workshop, we are going with Weave because it's a Weave net, because it's kind of an easy option. You guys are free to actually use anything outside, but for this workshop, we'll just stick with Weave. So here's a command, for deploying Weave in a single command. And if you actually look through it, you'll see that, as part of this, this single command, we have some interpolations in place, which do get the Kubernetes version and accordingly deploy the right version of Weave appropriate for the Kubernetes. So I'm just going to be pasting it. And
if you have questions, I'm here.
Yeah, please feel free to interrupt us at any time. We'll try our best to actually help you walk forward. So right now, yes. I'm sorry, can you? Are you using this environment here? Are you using PWK? Okay, that's interesting. Maybe I'll come and take a look at it, the next few. So the first thing, or the last thing I did was actually, in a single command, deploy the overlay network. And you can see, along with that, it also deployed, a service account, a cluster role, a role binding, and essentially the daemon set, which runs ViewNet. So now at this moment, if you actually go back and do a get nodes, you will see that the master now is actually ready. That's kind of an interesting observation at this point in time. So essentially, it is at a point where it can probably start accepting requests. It was just waiting for the overlay network to be up and running. And the same way, if you actually now check the pod status across all namespaces, you will see all the pods are running. So the interesting thing to note is that the core DNS pod will not come up until the overlay networking is actually set up. So that's a tiny observation at this point in time. So the next thing is, now that we have one master node that's ready and ready to move on, let's actually start adding more nodes, and let's see if we can actually add more nodes to the cluster. So I've just added another node. I'm going to be doing it one more time. So I'm adding another node. So I have 2 extra nodes now, but they are not yet part of the Kubernetes cluster. So for them to become part of the cluster, so I'm just going to go back to the master node, scroll up in my output, and find that join command, which is actually the command which is needed for adding slaves to the cluster. So I'm copying it from my output the same way you should be copying it from your kubeadm init output. So all you have to do is copy this, and then go back to each of the slave nodes, and then paste the command, and in the next few seconds you will see that the slave gets connected to the master, and it becomes part of the cluster. So the same way I'm going to do this for the other slave, and the same behavior, so in the next few seconds, you should actually see it become part of the cluster. Now, if you go back to the master, now one thing to note is that all the kubectl commands will have to be run from the master, because we don't have the kubeconfig information on the slaves. So from now on, other than the join command, you'll not have to run any other commands on the slaves. So go back to the master, and now if you actually do kubectl get nodes, you will actually see that there are 3 nodes, and all of them are ready to accept requests. So that's pretty much lab 1. So if you're here, you pretty much have completed lab 1. And at the bottom, I also have a cheat sheet, because it just sums up most of the commands which were actually used in this lab for you to get up to speed. So that pretty much concludes lab 1. Down to that. Yeah, if you do that.
Yeah, I did. Yep. Very good. All right. Hopefully you're with us. Given the fact that the material, I think most everyone is. If you don't, just again raise your hand. We'll be by. I think we're having the more times that we do this, the more success. Looks like we're having a high success rate. That's good. Exactly. Cool. Lab 1, you've got a 3-node Kubernetes cluster. You're ready now to deploy Istio. Let's talk a bit about Istio specifically and its capabilities and it as a service mesh. So we mentioned these things before: observability, resiliency, traffic control, security, policy enforcement. Lots of things promised. We shall see if they are delivered. Spoiler alert, they really are. Actually, maybe one thing to highlight that maybe isn't always declared, and that is that distributed tracing is, that much of this is provided with no code change, and that's of significant value to those deploying service meshes. For those wanting to get distributed traces out of their mesh, you do need to ensure that your application propagates span IDs, does propagate your HTTP headers. But that work is so much less involved than instrumenting your code otherwise. Observability with a missing graphic, thank you Wi-Fi, is the #1 reason why people deploy service mesh, to figure out what the heck's going on. And I think it's important to maybe clarify and set expectations accordingly that service meshes are, like we said, a services first network. It's focused on the telemetry that you get out of here is focused on network traffic and introspecting that deeply, but isn't necessarily going to be an APM. If you're thinking about observability in that sense, that hey, the workloads that are running inside your container, it's going to, to the extent that you use it for distributed tracing, you are going to get some insight as to what's going on inside that workload, inside your application. But much of the logs and the metrics that we're referring to in general are a bit more oriented towards the network traffic itself, how heavily inundated your services are, those types of things. Things that, outside of the containers themselves. Very interesting to most people. This is really what gets people hooked on service mesh. This is also maybe the easiest place to sort of ease into a deployment is with the uniform observability. That's because you're not necessarily affecting your applications. You're not telling it to behave differently. You're not telling the infrastructure to do something different. You're just saying, hey, there's tons of data flowing through here. Send that up to me. I want to take a look at it and get better insight. Many people do deploy a service mesh for these other capabilities, fine-grained traffic control, a bit of native integration with Annotation, like particularly in Istio's case, a really native integration with Kubernetes, and better control for a variety of use cases around steering traffic, maybe rejecting unauthorized users, maybe only allowing a certain, maybe providing multi-tenancy in your app, like without writing multi-tenancy into your app, maybe. Like to the extent that it's introspecting all of the packets that go across the network, to the extent that it opens it up, looks at some layer 7 things, finds that there's a certain user signed in, and that user is maybe associated with a different account, a different org, or some other moniker, that the mesh can redirect that traffic based on either a regex pattern that you've defined or some other label. It introspects all that traffic and can send it to different ways. Maybe send it over to your dark mode UI, even though you didn't actually create a dark mode UI, even though maybe it's helping you. I mean, I want to sort of expand your mind a little bit with some of the capabilities that a mesh could provide. Maybe it switches out CSS for you without you having to have made that code change. Maybe it turns out in the future we're defining dark mode for UIs inside of a service mesh. Maybe. Provides resiliency. So we talked about the ability to set timeouts and maybe timeout budgets, maybe deadlines. If we get a chance, we'll talk about those. Health checks for and circuit breakers, pool our connections. Also lets you inject a bit of chaos if you want, some latency, some jitter, some of those things. We'll pause here, let it soak in. Maybe my favorite slide. I just like to hang out here for a moment. It calls to me. Okay. What is Istio? And really, in my mind, we were talking about sort of what qualifies as a service mesh. Call me a pedant, call me bigoted and wrong, maybe, or call me a lot of other nice things. But I would submit to you that if the thing that's calling itself a service mesh doesn't have a control plane, I don't know that it necessarily meets the definition of a service mesh. And so let's talk about that a little bit. I think Istio, in this case, its architecture, two high-level components, a control plane and a data plane. For those that are network engineers or have done a little bit of are network savvy, these terms may make some sense to you. Even as you've gone to digest and understand something like Kubernetes, you hear the term control plane tossed around as well. So hopefully these two things make a bit of an inherent sense. So to the extent that control planes are out of band, that the traffic that flows onto the mesh doesn't go through the control plane. The control plane is where you define policy and configuration, how it is you want your mesh to behave. The data plane is where you're going to have, well, it depends on your type of deployment. For Istio, it's going to be probably a lot of sidecar proxies, service proxies. Many of them deployed. This is the plane that's going to handle the in-band traffic management. This is where all the traffic is going to flow through. Network traffic is going to be introspected, rerouted. Istio itself, primarily currently composed of three major building blocks, Pilot, Citadel, and Mixer. Well, we could talk about what each of these provide here in a moment. Maybe more interesting right now is the notion that application traffic is a good representation of maybe how it flows. So if you follow the yellow line, you'll find that in the past, and this is a Kubernetes example, and so in the past, you've had, in this case, you've got an application called foo, an application called bar. Foo, when it needs to speak to bar, would probably address bar, send it requests, and they would directly speak to one another. As you go to deploy Istio and the sidecar proxy gets injected into your pods, foo continues to address bar. It sends traffic its way, but unbeknownst to foo is the fact that there's a transparent data plane there. There's a transparent service mesh happening there that actually is the one that's intercepting the traffic, figuring out whether or not that communication is allowed or what to do with it, and facilitates forwarding it on over to the sidecar proxy for the other applications. So anymore, your applications don't Not only do these workloads not directly talk to one another, but neither does anyone sort of external to the cluster. Rather, all the traffic is intercepted. And hence fine-grained control over how all of this works. You're beginning to see a little bit of telemetry reports that can be emitted here up to Mixer. A lot of the capability, and for those, how many of you guys were at EnvoyCon yesterday? A few. Very good. And you'll note that the default proxy, the default battery included in Istio is Envoy. Envoy is probably achieving, or in my mind, achieving a lot of its objective around being sort of the universal data plane, if you will, or the universal component. Fantastic project. You've heard about it earlier in the keynote. You probably heard a crack about C++ somewhere in there, C++ 11 specifically. Point of curiosity for me, folks doing C++? Just as I suspect. Okay, yeah, good. Ton of functionality built into this project. Enjoying, who was at, actually, who's done reInvent, DockerCon, and now KubeCon over the last 3 weeks? Who's suffering massive jet lag with me? Yeah, solidarity, we're all right. Outside of that, who paid attention? Maybe the AWS announced a service mesh, app mesh. I just kind of highlighting as relevant recent news. They're using Envoy there as well. Lots of more examples of Envoy usage than we can probably call out. But that said, it is the included battery. There are a couple of other projects that have proven that that battery can be supplanted by a different proxy. Some of you might have heard about Engine Mesh in the past. So if you use Nginx, that was a project that helped you put in that proxy should you want to. That project, Engine Mesh, has since landed, or rather been closed down. Linkerd also at one point had shown that Linkerd could be the proxy or operate as the proxy within an Istio mesh. Neither of those two efforts are necessarily moving forward. Just there hasn't been a lot of or continued. I think one in part continued ask, also in part some of those vendors are focused on providing those capabilities elsewhere. So Pilot, the first of the three control plane components that we can talk about. Pilot's a bit of the head of the ship, if you will. It's the component that interfaces with your underlying infrastructure, in this case Kubernetes, gets receiving constant updates in terms of new service discovery, in terms of where services are scheduled or rescheduled, so that it has a continual understanding of the state of the cluster and where workloads are. So that it can then transcribe that into Envoy config in this case, and push that config down to each individual Envoy proxy. So that's a large part of its responsibility. So it manages that sidecar configuration. Mixer is a point of extensibility for Istio. It does a few different things, some precondition checking. It'll handle things like quota management. Maybe the rate limits have the threshold has been hit for a given API that you have. Maybe you got an unauthorized user. Mixer is the place where you can run any number of adapters to help you better interface with some of your incumbent tooling. And maybe that tooling is monitoring, maybe it's other types of tooling. Let's take a little bit of a closer look at Mixer real quick, because I think visuals always help me. If you consider that there's lots of traffic flowing through the cluster, and these sidecar proxies are seeing all that traffic. They're sitting there and they can just generate all kinds of telemetry. They're seeing all kinds of traffic. Maybe a simple-minded example that works well for me is if you've run Nginx or Apache and you go into the logs of those web servers, and then you see wgets, you see people, traffic going against your web server. In the very same way, you can see similar logs coming out of requests that are being made of your services. You'll also see a bunch of metrics being generated and pumped out. Same thing for the traces that come out. So those are all being sent up to Mixer, and depending upon what adapters you have deployed, there are many more, or a number more adapters than what I've represented here. We're going to go through a few in our labs. That'll help you integrate with your tools. Citadel is more or less is a certificate authority. Managed by Istio, helps provide a verifiable identity to each of the services, giving them a unique identity. It mints certificates. It's able to then hand those out, push those down to on the Sidecar proxies to the Envoys, so that you can then, if you want to, facilitate mutual TLS, some encryption between each of your services. It does that rotation and handling. OK, back to our labs. Lab 2, let's get Istio up and running. There is a tool for using Istio, Istio CTL, Istio CTL. I just want to CTL that part, just to be sure we're not cuddling anything today, just to be sure that I offend anyone who calls it something else. Okay, my job is done. Guys, all right, so let's jump into Lab 2. Back over to GitHub. I'm not even sure if Istio, we have the labs up here. So we got Keycloak lab.
Guys, if you have any questions, feel free to raise your hand. I'll try my best to actually, walk by and, help you move on.
Okay, lab 2, setting up Istio. I think that's all that we had in the. There's an optional component to this lab. So you do have, it is a bit of a choose your own adventure. You should see that up at the top. And that comes in, you've got choice of which adapters you want to deploy. If you want to try out the Istio adapter for AppOptics, Papertrail, or Loggly, do the optional component of the lab. If you don't and want to skip those, then just continue kind of straight through the lab. We're going to go through some of this. So we'll go out and, depending upon whether you're doing PWK or Docker for Desktop, we'll go out and grab a copy of Istio and our deployment files. And then Girish, where are we at in our? Girish, I'm not sure where we're at in where we've got our PWK. Can I swap out with you? OK, come swap out with me if you would. Yeah, I'm in Firefox. I don't see it.
Interestingly, I think we lost the session. I know, some people were actually experiencing the same problem. We probably either accidentally closed it or we lost the session. I'm sorry. Give me. You are actually free to actually proceed with Lab 2. Go on. I'll just try to do my best to quickly pick up speed and get there. So this is what I was trying to explain to many folks here. So the establishment between your browser and the servers are actually using WebSockets. So if your Wi-Fi has problems, or latency issues, then it's probably going to kill your session. In which case, you might have to start over. Yeah, just like this. But getting up to speed is very quick. That's the main reason, why I have a cheat sheet, especially at the end of Lab 1. Or you can actually just follow the commands pretty much here. And if you guys are already familiar with it, you should be able to get up to speed very quickly. So I'm setting up my Kubernetes again. Shouldn't take too much time. While that's coming up, I'm actually creating 2 more instances. And yep. So then I'm back on the master. So for the people who are actually following the Lab 2, it's very straightforward. So here we have choose your own adventure, like described. The only difference here is that we have a specific command for Docker for Desktop. Or Docker for Mac in the sense, the reason is the first command, it mostly works on your Macs or Windows or your local. there is a very high chance, sorry, there's a very low chance that like, Grafana and the security component like, will have a One thing to note is I've seen like, people run into this issue where you will actually see some errors, like, which are that, hey, I don't recognize this or that. Like, for example, you'll see a bunch of them. If you see that, that's okay, because what happens is when the kubectl apply does, so the Istio actually deployment contains a lot of moving parts. So there's a chance that there could be some out of sync issues. So in the sense, like, reapply the same exact command or rerun the same command, and it usually like, will get past that issue. So I have my cluster up in the next minute or two. And then I have to just get my CNI or the overlay network. OK, cool. So I think I pretty much am ready. kubectl get nodes. And yeah, I just have to give it a few more seconds. So I have this, if you walk through the tutorial, like, I have a watch commands in several places. Now, the interesting thing with watch is that, like, it actually waits and keeps, like, reapplying the same or rerunning the same command, like, every 2 seconds by default. Everything is configurable, but you can see that it actually will be on that screen. So now, I'm not sure if you guys noticed, like, some of the nodes are not ready, and now they are ready. So I'm just going to kill watch and come out. So now I'm actually going to be deploying Istio. So, and this is PWK, so I'm going to use the first command here. It just curls the file from our GitHub repo, and it actually dumps it to a local file, istio.yaml. And if you guys if you guys want to take a look at the file, like, feel free to using the VI editor on this on PWK. Even on your local, like, you're free to use your own editor to actually open the file and look at it. It is pretty long, like, because it's pretty much like, the way we have configured it is, it actually installs all the free add-ons, like, that come with Istio. Again, like, Istio deployments can be customized. But again, for this workshop, like, since the focus is on getting your hands dirty with Istio, like, so we have just chosen all the defaults and gone with it. So the file will be pretty long, nothing to be worried about. Also, there are other ways to actually deploy Istio now. Like, so the newer versions of Istio can be deployed using Helm. But again, like, for the sake of simplicity in this workshop, like, we're just using kubectl apply. So now I actually have the Istio YAML sitting right here. So I'm going to be doing a kubectl apply Istio YAML, and you'll see, like, it actually is deploying like a whole lot of things. So this is kind of where some people will actually see issues. If you see issues, just rerun the same command, and it'll usually be gone. It's again, like, due to the asynchronous nature of, like, the way the things are deployed. Now this actually has, like I said, like, deployed quite a bit of components. So we'll have to wait for them to come up. Now, if any of you are not using PWK or using, an older version of Kubernetes, probably version 1.8 or maybe even 1.9, you'll actually see an error like this, like, which says, some components, cannot be deployed because, this particular APIs are not available. That's fine. The only thing where you'll be missing is, now in the new versions of Istio, they have this automatic sidecar injection. So once a particular namespace is labeled, any pod that's deployed in that namespace will actually have a pod, have a sidecar proxy which is injected. Now, that's the only thing you'll be missing on. Now, how do we go about that is that, like, in this lab, we have this piece, like, where, we do have some steps for, manually injecting the sidecars. Like, that's also there. So if you have an old version of Kubernetes, like, it should still work. Not a big deal. But again, like, given the time, I'm not sure, like, if we'll be able to get there. So now, we should probably, like, given the time, like, we should have all the components up and running, which is what I'm going to check. You can see, like, pretty much, like, so a new namespace called Istio system was created, and a whole lot of components like Istio Citadel, Istio Cleanup, Istio Egress Gateway, Galley, Grafana, like a whole lot of things should be installed and up and running now. You'll see, like, 2 components that are still waiting, like, which is which is the galley and the sidecar injector. Now, they take a few more minutes, but usually once we actually get to the third lab, by then, you'll actually have everything stabilized. So this is good. If you see a similar output, that's fantastic. So now, one thing before we actually move on is actually that Lee probably mentioned about the mixer adapters that we had developed. One for App Optics and Loggly and Papertrail. Well, it's the same adapter, so we call it a composite adapter because it does multiple things at once. It actually ships metrics to App Optics, logs to Loggly, etc. So please do go to Lab 2. The optional Lab 2, and if you're interested, you can actually get your App Optics token from the lab resources spreadsheet, which Lee already mentioned, earlier during this workshop. But for Loggly, you have to actually go and sign up. Now, one thing to note is please do not use the email that's in that spreadsheet. Please use your personal email because what happens is for verification, it'll actually send a link to you guys. So if you use this email, you'll probably not be able to go move forward. So please use your personal email, for the Loggly sign up. Now for those who are there and who already have an App Optics token and a Loggly token, you just have to store it as a variable in your shell where we will be configuring our SolarWinds adapter. Now, in my case, I already have that handy. You can see here, I've just made a note of my tokens, so the App Optics token and the Loggly token. So pretty much, all you have to do is, store it in an environment, store it in a variable, and then go back to your browser, and then just paste it. So pretty much, so now the App Optics token and the Loggly token are stored as variables in the shell. Now, the other command, here, pretty much all it does is it gets the file from GitHub, and then it uses SED to kind of do an inline replace, of the placeholders with the variables, which we just stored in the shell. And then I'm kind of writing it to a new file called SolarWinds.yaml. So if I go back here and then run this, so now a file is created. So let's take a look at the file. So you can see at the top, the App Optics access token and the Loggly token are kind of injected in place. So now this file is pretty much configured to actually be deployed with Istio. So you can actually see that it actually configures a bunch of things like a log entry, handlers, and then the metrics, etc. So all those are this is how an operator would actually be configuring the mixer adapter so that the logs from the proxies will actually be sent to Loggly, and the metrics will be sent to App Optics. And again, those are SolarWinds products. Those are SaaS offerings. So hopefully, I'm not sure. I don't think we'll get to Lab 5. But if you guys are doing it on your own, and get to Lab 5, you should be able to see the logs and metrics, the appropriate SaaS offerings. So now we have Istio deployed and our mixer adapter configured. So the one thing which I have to do is apply the changes, which is in this file, and you can see that it actually created a handler, and then it created 2 rules, and then it also created a log entry. So it's as simple as that. So now Istio is deployed, and the mixer adapter is configured. So it's as simple as that. So this is again a command which is a way to verify if Istio is deployed. Now, even before doing that, if you guys are on PWK, the nice thing with PWK is that right after Istio's deployment, if you look at the top of your screen, you will actually see a whole bunch of blue ports that are being exposed. Now, this is the way PWK kind of shows the ports that are exposed. So it's kind of a nice thing to see. So, but we can also verify that using the all command, kubectl get all, and what this does is it actually shows all the components that were actually deployed in the Istio system namespace. And you can see a whole lot of pods, services, deployments, replica sets, horizontal pod autoscalers, and jobs that are actually deployed along with the Istio deployment. Everything is configurable. So, so that's kind of a nice thing with the new versions of Istio. Now, the next part here is that, talks about setting up Istio-CTL. One good thing is Istio-CTL is not mandatory because one great job which the Istio team did is they have actually leveraged the CRDs, the Kubernetes CRDs better. So now whatever commands, pretty much most of the commands you can actually run using Istio CTL, you can actually run with kubectl itself. So and again, for these of this workshop, I'll mostly be using kubectl for most of the commands, and kind of showcasing the workshops. Now, one other thing, like I mentioned, is configuring the add-ons. Now, as part of this install, I think if I actually can go back to the screen, you can actually see, if you go to the deployments, you can see Grafana is deployed in the namespace, Prometheus is deployed, and then Istio tracing is deployed. So these are actually optional add-ons, but nice to have, essentially, because essentially the whole purpose of, or one of the main purposes of deploying Istio is for visibility, and observability. So, so as part of this workshop, again, the deployment of Istio, I've deployed, all these components, but one thing to note is that, you cannot just quickly access them. So we have to do some tricks to actually, make them accessible. There are many ways to exposing services that are deployed on Kubernetes. Now, in this workshop, since the whole purpose is to keep it simple, I've actually showcased two. If you look at this particular section, which is talking about configuring add-ons and exposing services, I'm actually providing two options. One is option one using node port, so where we will be changing the Kubernetes service type from cluster IP, which is default, to a node port, so that it'll be just exposed on a port on the nodes. The other way is actually a bit more secure, which is actually a port forwarding. Now, one thing to note is on PWK, the node port is the easiest way to actually get it to work. But if you guys are actually using Docker for your missions, or running on a Linux cluster, or using some other hosted service, you probably might be able to use the port forwarding capability. Now again, so I'll just be showcasing again Grafana, for example. So how do you expose Grafana on PWK? So here's a command which actually does that. So it's nothing but so kubectl-n Istio system, which is in the Istio system namespace. I'm going to show how to edit the service Grafana. And now in this service, just go to the end of the file, and you will actually see the type. Now the type, as I mentioned, cluster IP is the default service type. I'm going to change that to node port. Now, one thing to note is, if you actually watch closely on the screen at the top of the page, where the ports are exposed, right after I save this file, a new port will actually become available. So I've changed the type to node port, and then I'm saving it. Yep. So I'm saving it, and you can see a new port was actually added. So, but again, how do you find that? Again, kubectl actually has a nice way of doing it. So just to change the edit to get service Grafana, it'll actually tell you the port number. So the port number is 31368. So at the top, just find that port, so 31368, and you just click on it, and it'll open it in a separate tab automatically. And in the next few seconds, you'll actually see Grafana load. So while that's loading, I'm actually going to be doing the same thing for tracing, or Istio tracing. If I think tracing is the name of the service. Now tracing is actually Jaeger. Okay, it's a bit slow. I'm trying to type fast. You can see right now it's not exposed, so I'm actually going to try to edit the service again the same way as I did for Grafana. I'm sorry? Right, so in the PWK environment, it has its challenges, because the way it's working is, I'm not sure if you are familiar with PWK or PWD. Every node you're seeing on the left is actually a Docker container. So it's double port forwarding would not work. So the way we have got it to work is that we have a proxy service that kind of makes this thing to work. So which is the reason why you have to use this node port. At least I have not tried the port forwarding on PWK and got it to successfully work. Maybe if you have great, it's good to know. Exactly. I mean, again, since this is a workshop and this session is only valid for 4 hours, you see the point, right? I mean, it's a very transient environment, so. But again, if you're doing it in your environment, absolutely, port forward is a better way. I mean, because it's secure, and you can actually kill the port forwarding at any time, and the port forwarding is gone. So I'm just going to be changing this to node port. And let's find the port, which is 32718, and you can see a port has now come up, and instantaneously you can see the Jaeger UI loading up. So the Grafana actually came up, so you can actually now meddle with it. The Jaeger UI is coming up, it'll probably take a few more minutes. Now, while that's coming up, so let's continue through the lab again. So I've just exposed, the two services, and we have Istio deployed, the adapter configured, and that pretty much concludes our lab for deploying Istio. So if you guys are mostly with us, then you should probably have Istio deployed along with all the other things I just mentioned, on your PWK instance or your local. And like I said, the instructions pretty much work the same on your local. So shouldn't theoretically have any challenges.
Okay, yeah, sorry, I don't know if I kissed it. Sorry.
Yeah, that's okay. I'll leave that running. I'm sorry.
Go, yeah. Hey, where are the slides?
Oh, where are the slides?
Nice, okay. Okay, so we are coming to the end of our 90 minutes. Thus far, hopefully, you've got a 3-node cluster. You've deployed Istio. You're beginning to get familiar with it. You've deployed some adapters. You're ready to deploy, like I said, this is a modified version of the canonical sample lab. I think it will, so we're not going to be able to, so I had hoped for Lab 4. Some of you have worked ahead. Some of you, if you complete the labs, I may see some tweets from you later. There's a bit of an Easter egg in there. I'll be looking for those. With the time that we have left, I think rather than describing kind of how the rest of the labs flow, they're pretty well described on GitHub. Those labs have been curated quite a bit. Rather, I think what's probably maybe more beneficial in our time left is two things. One, to point out a resource that I think might answer a number of questions that either haven't been asked or some things that I said that might need to be reinforced. And so one of those resources is, is this. I just got done publishing a report through O'Reilly that introduces service meshes, what they are, contrasts them with some other technologies. We talked a little bit about some of that today. Not as much as this report does. It's free. So if you're into free things from O'Reilly, like me, you can find it there. As a matter of fact, you can probably also find it on layer5.io. Nginx sponsored it, so I think you have to give up an email address to get it, but other than that, it's free. The rest of the time, maybe one other thing is if you've gone to layer5.io, there's a bit of an emerging project that I don't know if I told you, I'm coming from Austin, Texas today. If y'all couldn't get my southern drawl up here, but that is much funnier in my head when I do that. So there's another project that they're going to be working on. It's called Meshery. It's intended to be an educational playground for not only getting a bit more, maybe in an easier way than even we're doing today, maybe getting familiar with and manipulating a service mesh. Right now, it's Istio focused. We'll probably look to add compatibility with some of the other prominent service meshes. So I don't know, keep an eye on that if you would. I think maybe the rest of the time is the best spent fielding some questions. And so we'll either run over to you and give you the mic or, yeah. Yes, sir.
In one of your earlier diagrams, you had food talking bar, and there's the Istio Sidecar is one of those pods. When the food service calls the bar service, is it going to reference it using the HTTPS protocol or HTTP, knowing that MTLS will be done by the proxy?
Yeah. Yep, good question. So, so to repeat the question, if you've configured mutual TLS between your services, as you look at the communication patterns here, and you're seeing the sidecar to sidecar communication, in this example it's Nginx, but Is that communication going to be HTTP or HTTPS? So between services, it will be HTTPS. It will be secure.
Define HTTPS, service B, and then isn't that going to present 2 layers of?
Oh, sorry. Maybe I misinterpreted. So here, let me use a visual here. So HTTPS coming through, hitting here, a bit of SSL offloading, if you will. The loopback, or the communication that happens over local loopback here, unsecure, HTTP. And then
When product, say the product container is calling out to the details container, is it saying HTTP,
Right. The simple answer is HTTP, because the HTTPS is taken care of by the proxies. Yeah. So yeah. Sorry. Go ahead with your question. I'm sorry.
So the question on that is, it's really more around the sidecar communications.
Right.
So as a product, so we have HTTPS by default or HTTP by default?
I'll let you answer that.
TLS is mandatory
Right.
for security purpose,
Right.
right? So what
Right.
is the default communication channel?
good question. So to repeat the question, within the Istio project, do you get? Yep.
Sidecar, one sidecar to another sidecar.
Yep. So within Istio. Yep. So the question is, within Istio, is the sidecar to sidecar communication encrypted by default? I have to go look. In part, I have to go look at the quick start and whether or not that's enabled by default. I believe like the first one is. I think it's called out on istio.io. Like, hey, if you don't want to enable encryption, here's the way not to do that. So.
Yeah. So one other question was adding this sidecar pattern along with the app deployment. So did we see the amount of overhead? Do we have some numbers around it?
Yeah. Great question. So the question is, hey, there's a bit of overhead that's introduced as you go to inject sidecars adjacent to every app. And that overhead comes in terms of like CPU and memory footprint.
Adding another hop as well.
Yep. And it comes in terms of like, latency, introspection of the network packets and their forwarding. The answer is there is overhead. If you go to, in this case, Envoy and envoyproxy.io, explicitly that project states that they don't publish performance metrics because it depends on your infrastructure and on your, like so many things that, that said, that's super unsatisfactory to many. It is a real point of focus. It's something that's got to be done right. It's in part why C++11 is used. You'll find that other prominent service proxies in the space use something like Rust, another low-level language, to ensure that that's done super efficiently. You might have also seen like BPF, eBPF being leveraged in here to do things in the kernel. There is a project under the Envoy organization on GitHub that is I think it's Envoy Perf, that helps test Envoy specifically. That said, as you're using a service mesh like Istio, you're also including a bit of the control plane. Now the control plane isn't in-band, but there is some overhead in running that, and how quickly lookups are done and how quickly quota management checks are done. On istio.io, there is a performance page, and they do go through. So there is a talk I think later today that talks about Ford.io and some results from load generation testing. I think it's today. It's on Thursday actually, I think. Yeah. Thank you very much. Yes, sir. Maybe last question. Yes, they are. So just maybe last question is, hey, are these resources available? Are the slides available? Layer5.io is the hub for service mesh stuff, and so thank you very much, guys. I hope to see you around the conference.